So today we're going to be talking about web application privilege escalation. We're going to be doing a demo from the web attacks module, which is part of the bug bounty hunter path. The term privilege escalation is usually associated with operating systems. When we do CTFs, we usually try to get a foothold. We call it gain user, and then we try to escalate our privileges and gain root on Linux or gain admin user on Windows. But the term privilege escalation is not actually unique to operating systems, but it can be found in any application that has user access control. So operating systems, web applications, DBAs, thick clients, any application that has users and those users have privileges and rights, then there's potentiality for privilege escalation vulnerabilities. If we want to understand privilege escalation, we have to understand the difference between authentication and authorization. Authentication is verifying who you are. Let's take Instagram as an example. When you try to log into your account, it needs to authenticate you. And it does so using stuff like credentials, username and password, OTP, one-time code, and two-factor authentication, and so on, to ensure that you are the owner of this account. So once you are authenticated, then you can start using this account. So this is authentication. There are obviously vulnerabilities and flaws in this area, like authentication bypass and so on. But the area we want to focus on today is authorization. Authorization is verifying your permissions. So like I said, with any application that has user access control, the authorization part is verifying that you have permissions to do whatever action you want to do. Let's take Instagram once again. You want to preview like a private profile, for example. The authorization part is checking, do you follow this account? Do you have access for this account if it's private? If you do, then you are authorized to view their images and profile and so on. If you don't, then you are not authorized to do so. If you are not authorized to do so, but you are able to anyway, then there is an issue of access control, user access control, which is the topic that covers privilege escalation in today's talk. So now, with this distinction clear, we can move into our first demo, which is an IDOR. I'm gonna be using Burp. Last time I used the DevTools in the browser. This time, let's use Burp, so we can show both tools. And we have this exercise, which is part of the web attacks module in the IDOR section. And once we visit this web application, we see that we can see different documents and we can also see our contracts and so on. So these are private files and we can see them and download them. We also have the ability to edit our profile. When we click the edit profile button, we see that we have our, let me just zoom out a little bit. Yep. We can see our profile details. We can also change our profile details. Let's say test about me, whatever, and update it. And we see that it does get updated. So this is something very common that we see in so many web applications. And these stuff are usually in modern web applications. They are usually handled through APIs. So you're not usually directly talking to the database. No, you're usually talking through an API. If we go to Burp and we check our history, we see that whenever we visit the page, we get a GET request to this API. It says profile, API.php, and profile, and then this appears to be our UID. If we repeat this request, send it to repeater and send it again, we see that we indeed do get our user details. We get our UID, our UUID, our role, what's our role, our full name, and so on, which is the data that was shown here. Some of it at least is shown here. Other parts are probably used for configuration and so on. Now, the thing we should ask ourselves is, am I authorized to read this? I am obviously authorized to read my own profile details, right? But what if I change this to another user UID? Let's change it to user number 2, click send, and we see that we do get this information. In some APIs, this may be okay. Let's take Instagram once again as an example. If you are trying to view some private profile, some of the information is public, like their profile image, their profile header, probably their username or their name, and so on. These things could be publicly available, and anybody can see them. Even if the profile is private, when you go to the profile, you would see this information. So it's fine to find this information. This is not a vulnerability. It's intended to be publicly available. But in this case, we see some stuff that may not be private, like the email. It's very dangerous to disclose everybody's email. I can just change the UID and view their email. I can view their UUID and their role, which is also, as we will see, some private information. And this is what is called an IDOR vulnerability. Being able to read something that we are not intended to read and we should not be authorized to read, but the backend API allows us to do so anyway. We can change the profile to another user and we see that we also get different information and we do get their details. So this is one vulnerability. Let's keep it on our bag and perhaps we can get to it later. On its own, we can view everybody's email, perhaps send spam, view their private details. This is called information disclosure. So it is quite bad, but let's keep it in the bag and see if we can turn it into something more serious. The second part we want to talk about is, am I authorized to write this? What do we mean by this? When I updated my profile earlier, like I said, let's update it again, and we see that it gets updated. If we go to the proxy again, we see that it sends a put request. A put request with our details. We see it's our UID, UUID, role, and everything that we specified gets sent, and we get one confirmation that this has in fact been updated. To be able to know more about these requests, put, get, post, and so on, we must understand the CRUD API. This is mentioned in our very first module in the Bug Bounty Hunter path, which is the web requests module, and we discuss the CRUD operation. Basically, it's a create, read, update, and delete API. You are able to do these 4 actions through interacting with the API using different HTTP requests. If you want to get the data, you use the, or read the data, you use the get HTTP request. If you want to create a new user or a new entry in the API, you have to use the post HTTP request. If you want to update our profile, which is what we are doing here, we use the put request. And obviously, if you want to delete something, we use the delete request. So let's try to test the same thing that we just tested, but with the put request, and see whether we are able to update other users' details as we just did. Before we start testing this, let's think of what this can allow us to do if we are able to successfully edit other users' details. The first thing we may want to do is to obviously change our role. We want to become admin. Our role currently says, where is it? It says employee. We obviously want to be admin and escalate our privileges. This is one thing we can do. We can create and delete arbitrary users. Obviously, if this is a real production application and we have this ability and this vulnerability, then we can create any user arbitrarily and we can delete any user, which is a huge vulnerability. We can also change our UID. Perhaps if none of these work, we can change our UID to an admin UID, let's say UID 0, and we would get their privileges in this way. And finally, we can change another user's details. If none of those work, we can change another user's details, change their like about me section, perhaps put some XSS payloads, and whenever they view their own profile or anybody views their own profile, this XSS payload may get executed and we would be able to steal their hashes and so on, which is something we discussed in the cross-site scripting module. So let's try this. First of all, we want to change our role. Now we have this request. We sent it to repeater once again. Let's say we want to change it to admin. Let's see if it works. We hit send, and it says invalid role. Unfortunately, this role does not work. Perhaps we can just fuzz it and try administrator. Let's see. Doesn't work, alas. So this may not be enough. One thing we can do is try a word list with huge list of potential roles and run an application like FUF or GoBuster or even Burp Intruder until we catch a role. But this will not always work. Sometimes they use a specific word for the roles. All right, let's try the other one. Create and delete arbitrary users. So we said to create a user, let's send this to repeater again, we have to use the post request. Let's just change it to post. And see, now we have post. We obviously don't want to create user number 1 because this is our user and it exists. So let's try to create user number 100. Let's put this one here And we'll just give it the same details. Send. Let's just change the UID. Send. And we can now check if this has been created or not. Let's go back to this. Put user number 100. And nothing. So apparently it was not created. We did not get any error message or something. Let's try to change it to another user. Send. See what happens. Invalid role. Okay, perhaps that was the issue. Let's just say employee. Oh, now we get an error message. It says creating new employees is for admins only. We tried to gain admin access, but we failed. So the second thing also failed. What this is teaching us is sometimes a single vulnerability may not work, but if we, as we will see now, if we have multiple vulnerabilities, we may be able to put them together and chain them together and reach something that we can use. Okay, let's try the third thing, change our UID. Let's guess that. Let's just put this back to employee so it doesn't cause any issues. It says invalid role. Let's change our UID to user number 0. Perhaps user number 0 is usually admin. Usually, of course, not always, but let's just try. Oh, and it says UID mismatch. Okay, apparently it is testing this UID with whatever we put here. So what if we put 0 on both? Obviously, we are no longer changing our own because we are number 1 and now we are changing 0. But this is the last thing that we wanted to try anyway, which is change another user's details. Perhaps this is an admin with UID 0. Let's change their details. Let's change their role from admin to employees. So no one is that. And change, we don't get anything. Did it change or not? Perhaps user number 0 does not exist. Let's try user number 2. And it says UUID mismatch. So we are not able to also change their UID or any other details. Why? Because apparently it is checking this UUID, which is acting as an authentication token against our UID. And if they somehow do not match in their backend database, it will not allow us to. So this UID is acting as a security token. If we don't know it, we will not be able to change other users' details. So we tried 4 different things and none of them worked. This is the basic single vulnerability approach, trying just to change the data without having any other type of vulnerability. However, like I said earlier, we can chain multiple vulnerabilities. So let's try to do that. The other vulnerability that we found was the information disclosure vulnerability. And with that, we can view other users' details. Let's say user number 2. We saw earlier that we can view their details, but most importantly, we can view their UUID. So now we have the UUID of user number 2. Let's try to use this UUID and this request and see if we are able to change their details. Pay attention that their email is now Franklin, and this is their about information. So what if we send this request now? Now we get 1, which is the confirmation that we got earlier. Let's try to refresh the details. And indeed, we have been able to update their information. Earlier, we got UUID mismatch. But because we have this other vulnerability, which is the IDOR information disclosure vulnerability, we were able to find this missing piece, the UUID, and change their details. This is a nice vulnerability, but we have still not escalated our privileges. Well, technically, we are able to do something that we are not authorized to do so. So this is somewhat escalating our privileges, but we are still not an admin user. So let's see what we can do about that. So earlier, when we wanted to create a new user, we needed to be admin. And when we wanted to change our own details, try that once again, change it back to 101, which is our own user. So we obviously can, but when we tried admin, we got invalid role. So what is the missing piece in this case? The missing piece is the role. We need a valid role, a valid admin role, so we can use it. So what we can do is get the information of all users from, let's say, from 1 to 10, and see if any of them has a valid admin role. And if we do find an admin role, then we can use the admin role to update our own role. And if we don't, then perhaps we can try to fuzz for a valid admin. So let's send this to repeater, or to intruder rather, and try to fuzz. Let's clear this default thing and just add it on the UID part. For the payload, let's try, perhaps you can try numbers, sequential, yeah, let's say from 1 to 10, Step is 1, so 1, 2, 3, 4, and so on. And now we can start our attack. We can see it going, and if we investigate, if we just take a look at the responses, we can see that we are indeed getting different users. We go through all of them, and user number 10 has the role of staff admin. So we got all users' emails, which is good for like spam and whatnot. But the most important thing that we were missing is an admin role, and now we have it. So we can just copy it and just discard this for now, and try to use it. Where is it? Repeater. Yep. Try to use it as our own role. Staff admin, and we get 1. So apparently we have been able to successfully change our role. If we refresh our page, we see that everything works fine. Let's try to get our own details to see if it did actually change on the back end. Where is it? And yes, we have staff admin. So apparently now our role is admin. If we go to our latest cookie, we just visited our page, right? If we go to our latest request, we see that the request now says staff admin in the cookie. Now, as a disclosure, cookies usually are not obviously in clear text. They are usually encrypted or obfuscated. In this case, we are only keeping it in clear text just to demonstrate that our privileges have actually changed. And in reality, we don't care what the cookie is, because whatever privileges we have are stored in the backend. So even if we are able to, whenever we are able to change our actual role in our API in the backend, then whatever cookie we will get will be of that role. So we change it to staff admin, we will get a cookie for staff admin. Here we are just keeping it in clear text to show that we have actually been able to change our own user. Now, let's try the last thing. We have been able earlier to modify other users' details. So let's try to create a new user, something which we earlier have not been able to do. Let's copy this information, paste it here, change the request type to post, and we have to change this to 50 as well to match the UID. Moment of truth, we get 0. So did we create this user or not? Let's see. And we have successfully created a new user, something that we have not been able to do earlier. Let's try something like 51. Let's just change the UID to whatever. Okay, we are able to change users. So in the backend, we have actually changed our privileges and we have escalated our privileges. If we try it, we see that we have been able to create multiple users. The UID apparently did not become test because it is being automatically generated on the backend. So it can, store it and then compare it to UID as we have seen earlier. So this has been a basic example of how we can escalate our privileges within web applications using API vulnerabilities. We have seen how we can find IDOR vulnerabilities and then use it for information disclosure. Then we have seen how we can use the put and post request to find other types of vulnerabilities in this API. And then we have been able to chain two vulnerabilities together to be able to find other types of vulnerabilities and escalate our privileges to admin. Now, this is a very basic example, but in reality, this is something that is very common. In some cases, it is even as simple as this, as simple as directly interacting with the API. Very recently, I think this week, Instagram has patched a vulnerability where someone was able to directly interact with their APIs and was able to change the cover photo of any reel, which is a post in Instagram. So imagine you are able to change the cover image of any Instagram photo to whatever you want, even if it's not your own post. So this is a huge vulnerability, but it is the same type that we have talked about today. And they were awarded $50,000 as a bug bounty, which is why we are doing all of that stuff in bug bounty. I hope you can go through the web attacks module to get more information about these types of attacks, and then try the skills assessment, which has a more realistic example, something that is more similar to what you will find in real bug bounty programs. So this has been my talk, and I hope everybody had a good time.